Alright guys, so this is our pre-lab lecture for experiment 1. This experiment is designed to do a lot of things. It's designed to get you familiar with some basic measuring equipment, the meter stick, how a graduated cylinder is used, the different types of glassware and equipment in the laboratory. Alright, we'll have a special scale for you guys to use. It'll be quick and easy. It's a digital scale for mass. But you need to learn these properties of the different pieces of equipment in the lab. How many sig figs does a graduated cylinder have? How many sig figs will you measure mass to? How to do math with those different things. If you learn those now, it won't be hard later on in the year. Alright, so the pre-lab discussion takes you through the basic scientific method that we'll be using, what our observations are, why we're doing the experiment. Then it takes you through a vocab section. I recommend looking these things up. Alright? These are great vocab words. They'll let you gain some insight into the lab. Alright? Then we have a data analysis section. This is where you'll find the explanation for what we're doing and why we're using these analyses. Alright? Average gives us about, it's like the measurement of the accuracy of our different measurements. Alright? So it tells you how far you will be away from the true value of the 2.11 grams or the 2.5 grams and the 3.11 gram. And then we have standard deviation. Standard deviation tells you how close the set of data are to each other. All right? So it lets you see how closely packed the data is. What's the space in between each measurement? So that's really important. You can do this by hand, standard deviation, but it's very tedious and it's very time consuming. I'll show you a way on Excel that gets you an answer, boom, right now. Alright, and then the percent error, you have to realize that our theoretical values are the values I have given you in the lab manual. Alright, so your observed value is the value you get outside in class during your experiment. The theoretical value is the value listed in the procedures. Alright? Density is really easy. It's just mass of object over volume of object. We'll measure mass the same way, but we'll measure volume in two different ways. So what this does for us is it allows you to see that the significant figures matter. Alright? When we increase the accuracy of one measurement, we increase the accuracy of all derived measurements from then on. So you'll be able to see that, hey, if I use a graduated cylinder, it only reports 2 sig figs if I fill it to 5.2 milliliters. But if I fill it to 10.3 milliliters and then raise the volume, you get the same deflection, but it's a bigger volume deflection overall, so you get more accuracy. It'll be really cool, I promise. Then you will graph the data. And the reason why we do this is Excel is one of the most functional programs you will ever use as a student. This graph was put together in probably 15 minutes, but it's an incredible looking graph. I have standard deviation limits, averages, medians, means, everything with labeled axes right here. It's not hard to do once you figure out how to use it. It'll help in math classes every day. It'll help in environmental science for developing the line graphs that you'll make. It'll help in physics. It'll help in statistics, especially. It'll help in calc for a couple of problems. All right? So Excel is an incredibly useful and utilitarian programming. You need to learn how to use it. All right? Every single experiment almost will use Excel. So really get to know it. Don't just try to bite the bullet and get through this experiment. All right? So again, these are the theoretical values that you'll use in the percent error calculation. All right? So that's for pre-1982 pennies and post-1982 pennies. All right? These are our procedures. You need to figure this out and read all this. You need at least 100 pennies weighed out and then mark the year. But here's the thing. When you go down, you'll see your report sheet. All right? You need the year and the mass. you need to be consistent with the number of sig figs in your mass. All right? If you have 4 decimal places on the first one, then 2 on the second one, then 3 on the third one, I'm going to mark you off points. All right? It should be 5 sig figs if you have 4 decimal places. All right? If you have 3 decimal places, you should have 3 sig figs. You need to report the accuracy of your measurement. All right? So here we're going to talk about measuring accuracy. All right? On the graduated cylinder, you need to look here and you need to see in between these things. Water has a property called, well, not a property called, but it forms a meniscus. All right? This meniscus is, water does have a property. It's called adhesion. It adheres to the sides of the glass. Well, then gravity pushes down on the middle of it, creates a meniscus. All right? So we have this little bubble. You want to read the bubble down at the very bottom of the liquid. All right? Not at the sides where the water is on the walls, but at the bottom of the liquid. So right here, you want to read right here. All right? That's going to be, what, 17.5, 17.6? Some of you will get 17.5. Some of you guys will get 17.6. That's not that big of a deal. Big deal is that we're using 3 sig figs, all right? Now imagine if I'm down here at 5 or 6 and I get 6.5. When I divide by that number, now my significant figures are limited to 2 instead of 3 if I went up to 16 point something. All right? So the number of sig figs matters a lot. All right? So here we just have an example. You guys should understand this. This isn't very hard. It's just you just need the mass of the penny. In my example, it has 3 sig figs. In this example, I'm doing the density using a graduated cylinder. So right here we have 8.47 grams per milliliter. All right, that's roughly where the penny should be. Here's your report sheet. It's just all of experiment 1. Like I said, you need to weigh 100 pennies. That's why when you get into class, you need to start immediately when you start your experiment. All right, so you need to walk in, get started. The pennies will be out, and you just start weighing. Just start putting them on the balance, weigh it out, write it down. Mark down the year, weigh it out, write it down. All right. You guys can talk about what the group is going to do. If we can each do a water displacement experiment and a meter stick experiment, and then help out with weighing. So if you guys all rotate like in a big circle, then you guys are going to get done and it won't be hard. If one person is doing all the work, you will not be able to finish the lab. And like I said before, when we were in class, if you don't finish the lab, you just miss points on everything that you didn't finish. If I notice that, hey, you just wrote down numbers, there's going to be a problem there. All right? So this should not take a very long time. All right? As you can see, there's 10 measurements here that we actually measure. The rest is just weighing pennies. That should be the only thing that takes a hard amount of time. If you take 10 seconds per penny, you can still finish the lab, all right? Have a reporter, have a writer. And then the other 3 are doing these in a circular movement, all right? Go round robin. So if student or lab worker 1 does penny mass 1 in the water displacement, lab worker 2 does penny mass 2 in the water displacement. Then lab worker 3 does penny mass 3, right? And then we do the same thing. So lab worker 1 does penny mass 1 with measuring stick density. Lab worker 2 does penny mass 2 mass. So we can rotate in so that while we're doing it, everybody is weighing the penny masses, but everybody is also doing the lab. All right, that's super important that we get to work. Then down here, you'll see our post-lab questions. Calculate the average weight of a penny for both pre and post 1982 pennies. Calculate standard deviation, percent error. Then using the density data above, which method was more accurate? Shh, don't tell anyone. And is that same method more precise as well for calculating density? So now you need to know which method, what is accuracy and precision. Attach a bar graph correlating the number of pennies versus the weight. I'll show you how to do that. Attach the Excel spreadsheet. Show you how to do that. And then some other stuff. And so now we're going to move over to Excel, and I'm going to show you guys what you do with your data. So now I'm assuming that you've just taken the 100 masses, right? You have years and you have masses. Now in Excel, you're going to get a raw piece of data, all right? So you're going to have pre and post 1982 pennies sandwiched together. Now this is supposing that I took 40 penny masses. So what I did was I just separated out all the pre-1982 and then separated out all the post-1982. What will be easier is pre-1982 will be a lot more rare than post-1982. So just take those out and then the rest of them will be your post-1982, all right? But once we get this data separated, it'll be really easy, okay? So now Excel works on like a spreadsheet concept where these cells are independent of everything else, but they can be related to, all right? So what I'm going to do here is I'm going to select in the mass category the bottom cell, and I'm going to put in an equation. So you look up here and you see that this is an f of x. That's a formula bar or a function bar, all right? So I'm going to hit the equals sign, and that tells Excel, that tells the program that I'm about to put in a function that it has to do. It has to figure this equation out. So for right now, I want to figure out the average. So I'm going to type in average. It'll generate the most recent response for me or the most appropriate response for you. Type in average, and then do you see what's in between those two parentheses? I want to go in between those two parentheses and then click and drag down all the masses. Now what happens when I do that is it's telling Excel to calculate the average from cell F2 down to cell F20. So it's going to just do all the math for you as soon as I click enter. So now I have the average. Isn't that cool? I mean, you don't have to do any work besides doing that. So now I want to limit, because average is both an addition and a multiplication problem, you're going to be limited by the least number of sig figs in your experiment, which means that you need to bring this down to 5, okay? This can't be reported 2.5307992426, all that. That's going to get you marked off points. Don't do that, okay? We need to keep this in the same sig figs, same number of sig figs as the rest of the data. So now here's the cool part, because standard deviation takes forever to calculate by hand, especially on a set of data of 20, all right? But we can click equals. This tells Excel we're about to put in an equation, STDEV, parentheses, right? That's all you need. And then you select your numbers, the range of data cells. I'm going to select F2 down to F20 again. Don't include the average, all right? A lot of students want to pull it all the way down until the numbers stop. You just calculated average. We don't want the average in there, all right? So now we want to calculate the standard deviation. All right, this would take 20 minutes by hand. Boom, it's all done. That's all you have to do. Now this gives you the distance between each of your points and the average, or the average distance between each of your points and the average. So do you see how it goes 2.5307? Well, now standard deviation takes the average of the distance of any of these points from that average and then averages that out and gives you that average distance. So right here we have 0.0337. That's for our entire set of data. Each point is averaged at 0.037 away from this average of 2.5307. All right? Is everybody going good? All right. So now we're going to take the post 1980, or we're going to do this for everything. All right? So we're going to select these 2 points. We have the average and the standard deviation equations, right? So this is where it gets really easy. So now you see where my cursor turns black on this lower right-hand corner? This tells Excel to copy the data and copy the formulas. So my cursor is white in here. Now as I pull it down over here, it turns black. Well, now I can just select and drag, and boom, everything's filled in. Now it computes the average and the standard deviation for the years as well, which you don't need on the answer sheet, but it's still cool to do, right? because everybody's interested in the standard deviation of years on a penny. All right, isn't everybody interested in that? I'm interested in that. I think it's cool that the average penny year would be 1999 for a Poison 1982 penny. What did they do? Pump out just a ton of pennies in 1999? I don't know. Well, here, so now we've got the average and the standard deviation for both our sets of data. I mean, it's super simple, super easy, all right? And then we have the percent error. So we have to calculate the percent error slightly differently. It's still really easy. It's in a formula bar, but you have to separate it out. So now we're going to take the equal sign. We're going to go parentheses because order of operations, right? We're about to subtract something. So we take our observed value, right? 3.1114 was our observed value for the average mass of a penny in pre-1982 minting. Now we subtract that value from our theoretical value, which was 3.11 in the lab manual. Divide that by our theoretical value again. Again, that gives you the distance your average is from your theoretical value as a function of your theoretical value. So it gives you just like a percent range that you are away. It's a very good measure of accuracy. We got to multiply that by 100, remember? Because it's a percent. So right now it's in decimal form. So 0.045%. Were we pretty accurate in our experiment? Yes, we were. Theoretically, because these are all made up. But, guys, this is our percent value. So technically you should be around that. All right? Now, if you're at like 1%, don't worry. You know, that could be a calibration thing with the scales. Could be a lot of things. All right, so now I'm going to click and drag this all the way over again. Delete these because this doesn't matter. All right. Shift cells up. So this shouldn't be 3.11. The number should be, I keep wanting to ask questions like Dora the Explorer, like what should the number be? You guys can't respond in a video lecture. All right, so this is 1.28228. All right, so now it recalculated our input value as F21. So now just make sure that that's true. Yeah, that's F21. We subtracted it from 2.5 because that should be our theoretical value. So now in our post-1982 pennies, we had a lot more error than we did with our pre-1982 pennies. All right, so this is really cool. I showed you the function bars. This is what it should look like after. You just label these. You highlight the cells, and then once you've highlighted these cells, you can come up here and you can add boxes. So now this is your printout for the data. Special thing about printing with Excel is you select the sheet and then you come down here to print. It's going to be slightly different because it's a Mac, but you can fit everything to one page. If you guys give me 50 pages of data because you have 100 masses and you just didn't want to sit here and click the scaling option and print it on one page, I'm going to be mad. Not for grading purposes, but for the environment. Don't kill trees just because you didn't want to click a button. All right? Click this scaling button so everything fits on one sheet. Now I'm going to take you how to go through the volume measurements. All right? So we're going to do two density measurements. We're going to measure our density with meter sticks, and we're going to measure it with our graduated cylinder. All right? So the graduated cylinder is really easy. Right here, you're going to have really easy. You just get the deflection of the water from putting the penny in it, and that's your overall volume. You take the larger number minus the smaller number, that's your overall volume. All right? The density with the meter stick is slightly different. You're going to measure it in millimeters or centimeters. I recommend millimeters. Millimeters just gives you more sig figs. All right? So here, we've got 25.0 centimeters. And now you see that's the diameter, right? And our volume equation is 4/3 pi r cubed. All right? So just think for a second. 4/3 pi r cubed. Is that going to differ from our pennies? Yes, it will, right? Yes, it will. Because our pennies are technically our cylinder. So if you notice, when you go down here, there's a volume measurement. So it gives you the volume So right here, our volume is pi r squared h, okay? So now if we have our diameter, I'm going to measure it for our cylinder. Don't worry, I'm going to redo the measurement. This is pi r squared h. So this is for a cylinder. Don't get it confused, all right? So your pre-lab was 4/3 pi r cubed, all right? For a cylinder, it's pi r squared h. So now we're going to come back over here to Excel. And so this is diameter. So what do we have to do? Diameter equals this divided by 2, right? All right, so now this is our radius, right? So then our equation for our volume of a cylinder is pi r squared h. Well, what's the height of the penny? I don't have an example of a height of a penny. Let's go 1 milliliter, 1 millimeter, 1.00 millimeters. So let's go over here, 1.00, and this is height, millimeters, right? So Excel will always want to do 0 decimals, just add decimals with this thing right here. You can also delete and insert cells right here and select how you want them inserted. This thing right over here adds these boxes. All right, just giving you guys a little introductory course into Excel. So now it's pi r squared times h. So now we'll just type in volume, right? And just click equals. Well, now let's do this. So let's go equals, and let's do pi. And then r. And then square this. Uh-oh. I like to surround everything in parentheses as I'm typing in Excel. It just makes it easier for you to see, all right, and for Excel to, understand what you're trying to say. So always make sure that your order of operations makes sense in Excel. All right, so now our volume is 490 millimeters cubed. Now the other thing what I want to talk about is when we do dimensional analysis with that, turning that into a centimeters, our conversion factor is cubed, all right? So you just put 1 centimeter is to 10 millimeters, same conversion factor that we would use in converting millimeters to centimeters, but now we can cube that, and we can say, all right, that conversion factor is cubed, so now 1 centimeter is equal to 1,000 millimeters cubed. All right. So when you're using a conversion factor for a non-derived unit, you can make it a derived unit very simply if you just treat the unit as an algebraic quantity. All right. So now our volume is 490.9 millimeters cubed. All right. Or this is centimeters. We should do this in millimeters. We'll just change this and we'll say it's centimeters. Shh, don't tell anyone. All right, so our volume is 490.9, all right? So what do? Well, our density is equal to mass divided by volume. So density equal, and then we do equals, and we go mass divided by volume. Now the reason why I'm putting these in function bars and not just typing the numbers in and everything is because you're going to have 5 of those. Right? So to check your work, you put it into here, and then you can do really quickly density if you have your volume adjusted for everything, and just re-click your density formula, drop and drag down, and all of a sudden you have all your densities. All right? So now our density is 0.0509 grams per centimeter cubed. All right? So that's our density in this example. Is that a density that you're going to get? No, it's roughly about 8.5. Okay, but that just shows you how to use Excel to calculate density. The most important part is this right here. All right? Now, doing anything with that is really easy. All right, guys? We took this from a raw set of data and turned it into this very easily. All right, all I did was come over here, I typed down average, then I typed down standard deviation. If you ever want to extend a cell, you just come up here and double click the cell length and it'll automatically extend the cell. So we take over standard deviation, and then we take this and we just highlight these cells. We come up here to this grid quantity and we go all borders. Now all my borders are set, right? So now it looks good when you print it up. It looks good and you can easily read all these. Now, for our report sheet, when we come down here to our report sheet and it asks for these things for right down here on post-lab questions, you just have to put in the numbers and just say Excel spreadsheet, Excel spreadsheet, Excel spreadsheet. So we don't need to have a whole bunch of work for those problems, all right? What you do need to show your work on is these, the density problems. Those work is worth a bunch of points. So show your work, all right? It's really easy. You do mass divided by volume. The big portion that's hard is figuring out volume. So if you keep getting a density that's completely wrong, but your volume equation is completely wrong, you need to show me that so I know you know what density is. You were just calculating wrong, so I don't have to take off all the points. If you just have the wrong answer, I have no idea what you did wrong. All right, so you need to show me your work. That concludes our pre-lab lecture for experiment 1. Guys, just make sure you print out the entire experiment. Pre-lab assignment is due when we do the first experiment, and that is on your calendar, all right? Here, just make sure that you're using volume. I mean, guys, it's really simple stuff. It's really easy math. Don't make it too complicated for yourself. You guys are all smart enough to do this. It's not an issue of who's smart enough, who's more intelligent. It's just an issue of making it easy for yourself, all right? So that's the Excel presentation. Make sure that number 1 is done in Excel, all right, because you have to attach the set of data. All right, so you guys have a wonderful Sunday.